Okay, we are on 3.3. Now we are going to start a really fun game called as a product and quotient rule. So just think that first 3.1, 3.2 was a very basic level, and then now quotient rule and then product rule you can think as a kind of middle level of the derivative, and then after that we have a chain rule and then your favorite trig rules. So it's gonna come, so just keep building with the homework. So today I'm going to actually show you where we got the chain rule, where we actually got the product rule and then quotient rule. So look at this one. Ooh, looks beautiful, right? Looks beautiful. I'll organize what this means after I explain. This part, I just want you to see how I'm going to show you why we get such a complicated equation for derivative. So what is the product rule? This is a case before we talked about when function was multiply each other. I want to remember those shape, multiply each other, or sometimes we have function inside of the inside. So product rule means we have a function multiplying each other. So I usually circle. So what does that mean? As you see, we have a function multiplying each other, right? So that's we call it a product rule as a multiplication. Then just listen here. You don't have to write it down unless you really want. So I wanna find the derivative of when the two function multiplied. You see I have a two function multiplied. Then I want to take a derivative of this function. Then what does derivative means? What does derivative means? We are going to take a rate of change. So I'm taking derivative of this function and multiplying this times this. Then this means we have to use rate of change, right? When we do not know how to take a derivative, we're going to take rate of change. So what is the rate of change? I'm using official definition of the derivative. Just going to be x minus x plus h. I'm changing a plus h to x plus h so that you don't get confused. And g times x plus h minus f of x, g of x over h. Oh, are you okay, everybody? H goes to 0. So I just use the definition, just a plus h minus f of a over h. So I hope you see that. Then, Yonga, I don't know what this means. That's why I'm going to show you with a figure. So if you look at this, I'm going to set this one as f of x. And this one is going to be g of x. Then try to see that what they try to talk about. And multiply each other. What does that mean? Do you see as area? Bam! Yeah, so they're basically asking what's the derivative of area? So what is it? Then when you see this one, did you notice what this is? That is that blue square here. Then how about this one? I'm going to explain to you. So I have f of x. I'm going to increase my length, this one, h amount. So this I will call as f of x plus h. Make sense? That means I'm going to increase. So just think of it this way. I'm building a house, but from original one, I decide to extend that much and this much. So now my length of the whole thing, my extension, will be gx plus h. Then what does this mean? This means now bigger area. Do you see that if I multiply this one, I get fx plus h times gx plus h. If I multiply, that represents the area of after extension minus inside over h. What does that mean? I'm going to reanalyze this as different way. How? Well, if you have that big one, subtract this much, the area that I'm going to have is this much, how much I extended, how much I expanded of the house. So I want to find this area, that's the differences. Then how can I write this area here? This area, I can write it as height is f over x. And then what is this? That is, I'm going to use a really cool symbol, changes of g of x. Okay, do you understand what this means? So that's the changes of g, how much the function changes. And then the next one is going to be this area. Can you guess? So this area has to be f of x times g over x. Changes in g. And then this is going to be now, as you see, g over x times this will be delta G, delta F. So I'm going to multiply delta F. This notation is actually wrong. Okay. And then what about the small one? That's going to be delta G times delta F. The changes of G, changes of F, they multiply of the differences. This triangle means differences. So differences of G. So why I'm doing that? Subtracting here to here is actually adding this plus this plus this. So I'm going to write it down, those three, this plus this plus this. So f of x delta g plus g over x delta f plus delta g times delta f. Okay, almost there. So from here, what we do, now we can separate this limit. So it is going to be h plus h plus h, and then f over x delta g, g over x delta f, delta g, delta f. Now carefully look at, what does this mean? I said that's changes of g over h. What does that mean? Change over g means, do you see that g over x plus h minus g over x is this guy? So if you put that one over h, do you see that another rate of change? So that's the rate of change of g. So I can rewrite this is going to be f x times g derivative plus, again I have a g function x, then what does that mean? Changes over f. How do I get that value? Subtracting this one over h. That is the definition of f function. Then Yona, how about here? Yeah, almost there. Do you see that I can rewrite as g derivative of x? Then how about this one? I'm gonna do some math trick. We do that common after calculus class. I'm multiplying h and h because that is also derivative of f function times, now I have h. Then I still have my limit h goes to 0. Do you see that none of them have h, but this one goes to 0, that whole this thing is going to be 0. So the function that you have is f over x times g derivative of x plus g of x times f derivative of x. Woo! That's how we got the product rule, and I'm going to show you what this means. So look at this one. I have two functions, f and g. I want to take a derivative. That means you are going to take a derivative of, you leave the first function. Do you see that? I don't touch the first function. And then you are going to take a derivative of second factor. That's derivative. And then plus, now you are going to keep g function and then take a derivative of f function. I hope you see the pattern. So what I do is leave it, take a derivative, and then leave it, take a derivative. You can just do that. I may switch it other way around because that's how I learned. Okay, let me explain to you quotient rule. Quotient rule is actually this over this. So what they're basically doing is they put as a product rule. Do you see that as a g of x to the negative 1, right? Because the denominator. If you take a derivative of this one, do you see as a negative 2? That's why you have a square here. So bottom, you're gonna get bottom square. Bottom square. Top is the tricky part to remember. How I remember is take a derivative of top and then multiply whole thing, subtract, leave the top, and then take a derivative of the bottom. Okay, so I will explain to you with some example here. If I want to take the derivative of this one, actually, if I take the front part, I'm going to use this way. Let's just everybody try to stick. Take a derivative and then leave it. I'm stick with your book, plus leave it and then take a derivative. Take a derivative and then leave it, plus leave and then take a derivative. That's how I memorized when I was in school. And then next one, you can follow this rule. So take a derivative and then leave it, minus leave it and then take a derivative over bottom square. That's how I remember. Because if I have this one, I can just use a subtraction and then bottom square. So let's look at example here. If I look at this one, I see that this times this. So take a derivative, this one first. 6 times 3x squared. And then leave it, which is a 7x to the 4. Plus, now I'm going to leave this one, 6x to the 3rd times, now I'm going to take a derivative of this one. That's going to be 28x to the third. So if I simplify, that is going to be, ooh, pretty ugly number. Okay. 21 times 6, 120, 6x to the 6th power plus, ooh, I don't like it. It's going to be 28 times 6. Hope mine is correct. 168x to the 6th power. So I think you can add it. 294 x to the 6th power. But did you notice that I didn't have to do this way? I could do this way too. Do you see, since those are the powers, I can all multiply. So can I do just this way, Young? That makes and then x to the 7th power, which is 42 times 7 times x to the 6th. Yeah, exactly. I get this same answer. Oh, that's 4, right? I get the same answer. So that's why I'm saying you have to play and then see which one will be faster for you. It only comes with playing. So keep playing. On the homework, it's going to be very tedious. It's going to be very annoying. But just to think that you are getting ready for chapter 4. It will show on chapter 4 who's been practicing. So let's look at the last my example. And then I will show you another. So here I have a function x squared over 1 minus x. Yes, you can do this way, x squared and then times 1 minus x to the negative 1. But as you see another circle, we didn't learn that rule yet. So you have to see quotient rule, we use it circle over circle, and then follow the rule carefully. So I'm going to take a derivative of the first one, which is 2x, and then leave it, minus, now leave it, and take a derivative over bottom square. Now organize a little bit better. So it's going to be 2x minus 2x squared plus x squared over 1 minus x squared. If I combine them, 2x minus x squared over 1 minus x squared. If you plot by x, it's going to be 2 minus x and 1 minus x squared. I try to say anything simplified. So you can leave your answer this way or that way. So that's my derivative. As you see, it gets long, right? So careful. And then I'm gonna show you 3 more examples, and then you're gonna do next 3. So let's find the derivative function. First, let's see how their function look like. Can I use regular power rule, exponent rule, quotient rules, product rule, and chain rule? So when I look at this, look at how many functions you see. I see this way. I want you to keep practice. If you see the function, also do you see that this times this? And this one, I cannot even see here. So this times this. Okay. So now, if this is a rule, then we can take a product rule, right? So let's take a derivative here carefully. As I said, what was the formula? Take a derivative of first one, leave the second one, plus leave the first one, and take a derivative of a second one. So let's take a derivative. That's going to be 3x squared, and then leave this one, 2 to the x, plus, now leave the next one, and then take a derivative of 2 to the x. Remember, I'm gonna have my number itself and then multiply base 2. Yeah, that's it. Now we have to organize. Do you guys see common factor? So this time, sometimes nice to factor it out. I see that 2 to the x, 2 to the x. You can factor out, and then you can leave it all the way, if that's fine. Because sometimes we like to do that to separate the different functions. Like that. Or it's okay to pull out x, and x squared, then 2 to the x, and then you are going to have a 3 plus natural log of 2x. Okay. And why is this important? When you go calculus 2, you're going to go backwards, okay? Cal 2 will end of this semester, also we're going to go backward. In Cal 2, you guys are going to do more complicated one. So you have to practice this direction in order to see Cal 2 with you going backwards. If you don't see that direction, you're going backwards, you're not going to be able to see that to take an integral, which is the opposite operation. So keep practice. Okay. So I think I'm happy. Personally, I'm happy with this answer. But if your book shows this one, I'm happy about that too. Or it could be that one we organize. So let's keep playing. Let's do B. So B is also same way. I just make it big. So if I take a derivative, I said take a derivative of first one. Or if you forget, just make a circle. I used to do that. So take a derivative, leave it, and then leave it, take a derivative. So you just take a derivative. That will be 6t plus 3. And then leave it. That means just a copy. And then next one, I'm going to copy. And then last one, take a derivative, which is itself. Right? And then now, can I factor out anything? Do you see any factor? So if you delete this one because that confuses me, then I see that common factor e to the t. That's it, right? I don't have a t here. So common factor e to the t, and then rest of them I'm going to put inside. 6t plus 3 plus 3t squared plus 3t. Oh, I guess I can pull out 3. Then 3 e to the t makes, sorry, I'm gonna do 2 steps at the same time. That's going to be plus 3t plus 1. Am I correct? Hopefully I didn't make a mistake. I did 2 steps. So this one pull out 3. This one is a 9t pull out 3. 3 pull out 3. So this is what I get. And there's one more C. Let me see if I can squeeze here. So C, and the question is 3 times 5 to the x plus 3t. Ooh. I will squeeze here with your space. So same way, this one and this one, actually I'm going to use product rule, and I want you to see that if I can get the same answer of back there. So can I write it x to the negative 2, right? So I'm using this one, and when you look at this, let's take a derivative. So take a derivative, that's going to be 3 times 5 to the x and ln 5, more parentheses better, plus 3. So I'm done with taking derivative of front part, times leave it, and plus, because I'm using product rule, leave it, and then take a derivative. Get it? Negative 2 come front, and the x lower 1 power, and then make sure you put parentheses. Then now I wanna staring at it. Any common factors? I don't see common. Oh, I see common factors. It's going to be a little hard. Okay, I see common factor as x to the negative 3. I see common factor as x to the negative 3. Youngah, why x to the negative 3? Why not x to the square? Think about, if you have an x cubed plus x squared, do you pull out big number, small number? You pull out small number, right? So I have x to the negative 2 plus x to the negative 3. Do you pull out small number? Small number or big number? Yeah, we pull out small number. So that's why I'm pulling out negative 3. Then, Youngah, that was a negative 2. What am I gonna do? Well, that means you have a bottom here like this way, right? So I'm gonna multiply x and x. That gives me x to the third. So if I pull out, x to the third, now that's what I pull. So in my numerator, you're gonna have x. So x times 3, natural log of 5 to the x plus 3 times x. And then between here, I'm going to have a plus. I know, this one I already replaced as this one. And then I pulled out, and then I'm going to factor out this one. I'm going to have 3 times 5 to the x plus 3x minus 2. And then parentheses. Now, do you really have to do this? Yeah, do you see that there is a number? You can combine it. So let me pull out a little bit more. So I have x to the negative 3. And then top I have 3x natural log 5 times 5 to the x plus 3x. Plus I have a negative 6 times 5 to the x negative 6x. So I have to combine this one to this one. Then that is going to be x to the negative third. So you have to put 1/3 and then rest of one. 3x natural log 5 to the x. It's kind of a ugly number, right? 3x and minus 6 times 5 to the x over x to the cube. That's the derivative. Pretty messy. I hope mine was correct, and I want you to try one more. Okay, so before you do in-class activities, I decided to actually show you using this one with quotient rule. So let's see if my answer is matching with this one. It's gonna be the same, right? It's gonna be correct. So let me write the answer one more time and watch me again. I want to take a derivative of my question is 3 times 5x plus 3x over x squared. So let's take a derivative using quotient rule, which is I'm going to put this one over this one. So the rule is take a derivative. So 3 times and natural of 5 to the x plus 3. Take a derivative and then leave it, careful, this time is x squared is your function, x squared plus minus, it has to be minus. Now leave it, so don't touch. And then now you're taking derivative of x squared, careful, that's a 2x over x to the square, x squared over square. So why you have to factor out like this? Because of if you don't do it, you're not gonna get same answer. So watch from here. Do you guys see common factor? I see common factor as x. So pull out x and then write it out everything. So I'm going to organize. That's going to be 3x natural of 5 and 5x. Where I got the x, because I pull out x, I had an x here, which I distributed, plus 3x. Okay? So I pull out 1x and then 1x left, then I distribute it. And then I have x out, so I have a negative 2, so negative 6, 5 to the x, negative 6x over x to the fourth power. So we're almost there. If you see it, this x and 1x can cancel out. So rest of them, 3x natural of 5 times 5x. You notice the common factor, which is a negative 3x minus 6 times 5 to the x over x to the third. If you see it, exactly same answer, right? 3x ln 5 to the x minus 3x minus 6 times 5 to the x over x cubed. That's why you have to simplify all the way. So I show you with the quotient rule and the product rule. When you do this one, your front part is the same, but you have to use your g function. This one is going to x to the negative 2 since you brought it up. So careful, then you will get the same answer. So here's a 1, 2, 3. I know you need a little bit more space, so just do it and then let's do a couple more practice. This is it. Okay, so let's compare my answers here. So first one, I got this. Make sure you guys factor out, and then second one, hope that you guys are correct answer. So I approach with the product rule, and then make sure you factor out. This one a little bit tricky. What I do here was I use x cubed, which means I basically use x times x cubed, which is x negative 2, right? So that's the rule I use, which is 1 over x cubed. So I pulled out that. So I got this answer. I omit some of the work, so you have to find there's a remain x, just that should be distributed. Same thing happened here. I'm skipping 1 or 2 steps, and I want you to get familiar with skipping or doing your algebra a little bit faster. If you approach either way, you will get the same answer. Okay, so I'm going to actually explain 3 more on main dish with the quotient rule, and then if you want to actually challenge yourself, also do it and compare with me, but it's going to be a little tedious, so keep practice, keep practice. As you see 3, 4 steps, you can do it, right? You take a derivative of the function. So this one, if I take it, I can use the either way, quotient or product rule. So if you want to take the quotient rule, you can keep it this one, or if you want to take the product rule, you can just write it as x cubed minus 1 to the negative 1. But as you see, this function, we haven't learned it yet. So in this case, you have to take the quotient rule. So quotient rule, the rule is minus 1, not minus 1, prime is now take the derivative and leave it, minus, leave it, and take a derivative, over denominator square. Now organize the numerator. So I see that 2x to the 4 minus 2x minus 3x to the 4th power over denominator. And if you organize, I get to see that negative x to the 4th power minus 2x over x cubed minus 1 squared. This case, actually we have to factor negative x, and you're going to have an x cubed minus 2 over plus 2, and then x cubed minus 1 squared, because sometimes you can factor it out, right? So that's the answer. Let's do one more. So I'm going to take a derivative of this one and make sure I always put this guy. So quotient rule is I have this, circle this. Take a derivative with me carefully, use more parentheses. Did you get that? Pi is a constant, so drop it, and then e to the x, leave it. This one minus, and then leave it. And then take a derivative, which is itself. Over, don't forget, denominator, square. So now I'm going to organize by factoring e to the x, and then I get 2x plus 10 minus x squared minus 10x minus pi. You following okay? I have e to the 2x, then e to the x inside, I get negative x squared, negative 8x plus 10 minus pi over e to the 2x. What is that? That's e to the x times e to the x. Is it, right? So that one cancel out, and then rest of them will be answered. If you want to pull out negative, that's fine. Without it, that's fine too. So minus 8x plus 10 minus pi over e to the x. That's the derivative. So hope that you got the same one. There's two more waiting, and then there's one big review. So I want you to try the next question. Compare new answer. If you got that one, very good. I use the quotient rule, but I want you to see that if you can approach a different way. I wouldn't actually use the quotient rule because it's a little bit complicated. So I'm going to separate my denominator. Do you see that I can separate it? That makes now x plus 3 over x. Now I'm going to take a derivative. X, if I derivative 1, plus this is going to be same as 3x to the negative 1. So 3 times negative 1 comes from, and then x to the negative 2, organize. 1 minus 3 over x squared. Do you see that? I get the same answer, but I use the power rule. You know, how did you see that? Well, when you play more, you see more. That's why. Just play more, that it will come to you because you will see the pattern. Next one, this one was also straightforward with using quotient rule. So I got this, and hopefully I didn't make a mistake. Look at next one, 1, 2, 3, 4, 5, 6, 7, 8, 9. I have 9 terms. So compare, I skip all the work, but I want you to be able to do mentally like this. So compare each of them. This one, what happened after I subtract, I got x to the 0.1 minus 1 is x to the 0.9 negative, so I put in the denominator. Okay, now there is 2 more. These are look familiar, so I want you to do it again and then compare with me. Good job. The last 2 questions of your dessert. So now I want you to find the tangent line and normal line. I'm gonna explain what normal line is. Normal line is we using Cal 2, Cal 3, Cal 4. Normal line means the graph with a perpendicular slope. We just say normal line. So just you say it's a tangent, and then that's a normal line. Okay. So when you look at here, I want to find the tangent line. That means for my function, I have to find my derivative function. So by using the quotient rule, I got my answer here. Please look at my work carefully. And all I did trick was here, I made a common denominator by multiplying 2 root x. And then after that, I pull it out in front here and then organize. So look at my work one by one. So that's my derivative. And then after I plug in 1, I got the derivative slope at 1 was a negative 1/4. So using the point 1 comma 1 over 2, nicely they gave it to me, but you can actually plug in, right? Then you get 1 over 2. So this is my tangent line equation, which means if I have a function, you can graph this one with using some Desmos, and this function will be some weird function. And when you look at point here at 1, what is this graph? Because a tangent, it touches here, that's a tangent line, and that's my answer. Then what is a normal line? This is a normal line. It's going through perpendicular to your tangent line. That means I'm going to have exactly same point passing through 1 comma 1 over 2. But what is going to be my perpendicular slope? Which is going to be negative 1 over 4. When do they use that? Like think about the earth. And then those are something is going to drop down, and then you can find the tangent line. But this factor, this kind of line, when it goes straight into the earth, those one we call as a normal line. So using this one, y minus 1 over 2. Oh, big mistake. It's going to be perpendicular slope should be 4. So 4 and x minus 1. So if I organize 4x minus 4 plus 1 over 2, so I get 4x minus 7 over 2 as my normal line. I just want you to know those words. So that was it. In class activities 3. And then let's continue example in class activities 4. If you want to pause it, think about it, please. It can be confusing. So this time I'm going to manufacture product of the bolt of a fabric with a fixed width. The cost of producing X yard of this fabric costs this much dollars. So what's the X? X yard. And then Y as dollars. Then what is going to be meaning of the derivative? They're gonna tell me cost per yard, right? So what is going to be the unit? Then unit is going to be dollar per yard, right? So that's why it's important to write it down. Then what does this mean if they say derivative of 1,000 is equal to 9? Just what was input? Input was 1,000 yards. So when you manufacture 1,000 yards, how much the cost? It's going to be $9 to manufacture. $9 per yard. That's going to be their cost, right? When they manufacturing 1,000, when they manufacturing 1,000 yards, then it's going to be unit price of $9 per yard. It's going to be. Then right below, if you look at, you have a f of a 5, f of a 50, and f of a, what are the numbers? Sorry, I will switch. 500 and 5,000. So when you look at this one, which value is going to be bigger than this one? So 1,000 will be in here. So now my question, is this number going to be bigger? Unit price will be bigger or less? Or this is going to be bigger or less? What do you think? I think this one will be higher, maybe $10 per yard. Why? Because you don't make it much. So factory is not going to give you a good deal. But if you're making 5,000, then they probably going to give you per price as like a $5 per yard. So I want you to see that when you look at this question, do you see your actually slope is going to be less when you're actually manufacturing more in yard than you're manufacturing less. So I want you to see there are differences of building it when you are in real situation. Okay, so that's about the 3.3. So enjoy your homework and I will see you in 3.4. Good job.